Hello everyone again. So, we're back in the same old situation that we were before. If anyone can name that riff, I'll be very impressed. So where are we? Got one more lesson of Venn diagrams to go, for which I've chosen, well, I'd like to say cheddars, but strictly speaking they're called cheese thins, the variety I bought. Not the greatest to dunk in tea, but a great one to eat about half a packet in about 10 mouthfuls. Right, so without heading about, we'll crack on. There's a couple of formulae coming up which are in the formulae booklet, but it's good to know where they're from, otherwise you probably forget where to use them when you need them. Okay, the two formulae we're looking at today are on page 7 of the formula booklet. Under probability, there's just a few formulae here, and the first one's so obvious as to be it's something that you've known since year 7, if not even earlier. The probability of something not happening is 1, take away the probability that it does happen. So all probabilities add up to 1. Then the two we're going to look at today are this one here, followed by this one here. So looking at this one first of all, probability of something being in the whole thing of A or B is the probability of A plus the probability of B, but take away the probability of the intersection. Now why does that happen? Well, we could think about this by thinking about what happens when we roll a dice. That was lucky, wasn't it? Got a 6. Anyway, so yeah, we could be doing that. So let's think about what that formula was in the first place, so that when it comes to an exam we know which questions it's helping us for, and when you look at it you know whether or not it's going to be helpful straight away. So what's going on? Let's say we've got a dice. Our universal set, what would that be then? Could have a 1, a 2, a 3, a 4, a 5, or a 6. And then we could have, if I say my set A is going to be multiples of 3 and my set B is going to be even numbers, I could make sense of this with a Venn diagram. Now I'm going to draw two Venn diagrams here. One, because you can use a Venn diagram to sort data out of it for you, and the other one just to show the actual probabilities. So we've got our A and B, our universal set, and our universal set. So we know that it's all the numbers from 1 to 6. Odd numbers that aren't multiples of 3, 1 and 5, are both going to be going outside there. 3 is a multiple of 3, but it's not even. 6 is a 3 and it's even, and the other even numbers are 2 and 4. So now I could transfer this into a probability Venn diagram, saying I've got a 1 in 6 chance there, a 1 in 6 chance there, a 2 in 6 chance there, and a 2 in 6. I'm not going to bother simplifying them, so we've got the same denominator. Now, what's going on here? What we're saying is I know the probability of A is 1 6 plus 1 6. There are 2, aren't there? There's a 3 and a 6, so that's 2 out of 6. I know the probability of B, that's 2 out of 6 plus 1 out of 6, making 3 out of 6, or a half. Now if I want to know that probability, I can see that A intersection B is 1/6 there, but if I was going to get it by doing something clever, knowing what A and B, what am I talking about? We're then going to talk about, right, so that's 1 in 6. If we say, let's look at this formula that we've been given, A unisection B, and I want to know what that is, and I know that the probability of A is 2 out of 6. I know that the probability of B is 3 out of 6. But if I add those together, I get 5/6, which is 1/6 too many. And that's because I've got half of my probability of A is already in there. I've already counted it in. And then I've counted it in again there. So I don't want it twice, I want it once. So I've got to take one of this lot away. And that is what this formula is doing for us. Now I'm going to pop an example on up in a moment. I'd like you to copy it down, have a go, pause the video before I explain it, see if you can work it out for yourself, because it's just fairly simple, I think. Right folks, here's our problem. So write it down, have a little bit of a go at it, see if you can get there. Just looking at our formula, we would have probability of B being probability of A plus the probability of B, but then we don't want to have this bit twice, so it would be, and then we can rearrange that so that we've got, by adding that to both sides, probability of A to B, and if we take this one from both sides at the same time, then we should end up with what we want. So we've got 0.6 plus 0.7, and then we're going to be taking 0.9, which is a good job because this adds up to more than 1, which isn't possible, is it? 1.3 take 0.9 gives us 0.4. Always a nice idea at the end to just check it makes sense by using a Venn diagram. That's not really large enough. So what do I know? I know that all of this is 0.9, so I know that should be 0.1 there. They've told us that we've now worked out that would be a 0.4, I mean 0.4. Probability of A is 0.6, so 0.4 plus 0.2. B is 0.7, 4 plus 2 is 6, plus 1 is 7, so that gets us there that way. Now, whilst I've got this Venn diagram on the board, I'm going to use that to help us into our next one, which is to show you first of all where the other formula comes from. Right, if I say the probability of B given A, in this instance, it's not 0.4, it is 0.4 divided by all of A, isn't it? Which is 0.6, which is 2/3 if we simplify it down. So the probability of B given A is that bit up there, which is A intersection B, which is the bit that we want, divided by all that it could be, because we know that it's A. Now the next formula in the formula booklet that we looked at a minute ago is just a rearrangement of that, and it's something that's not immediately obvious. So all I'm going to do is multiply by the probability of A both sides, and I get the probability of B given A times the probability of A gives us the probability of A intersection B. So we worked out, so that means that 2/3, because that was the probability of B given A, wasn't it? That's what we just worked out, multiplied by the whole probability of A, which is 0.2 or 2/10, would give us the probability of A intersection B, which is giving me 4/30 there. So what have I done wrong? The probability of B given A was 2/3. The probability of A was not 0.2, was it? Yeah, I'm sure lots of you have noticed that. It's actually 6 out of 10, isn't it? So if we did that, that would give us 12/30, and we could write that down to 4/10, which is what we've got there. Now I've stumbled through that. I was going to say deliberately, but I wanted you to see where the logic came from. It's really simple, but at the same time it's not necessarily, it's a little bit counterintuitive in a way when you look at it straight on. Right, here comes an example for you to have a go at before I take you through it. Right, here's your 3 problems. Pause the video, have a go. A little reminder if you need it. C intersection D, D given C, and C union D. That's any of them, isn't it? That's the and that's the or. Right, so what does our formula tell us? It tells us that the probability of B intersection A, or A intersection B, is going to be the probability of A times the probability of B given A. Now this is important. We've got the A involved both times. You've got to have whichever one you're going for, you've got to have the probability that you're using. It's got to be the one that's the one that you're given. So we're looking for the probability of C intersection D. So it's the probability of C given D, isn't it? So that means that we want the probability of D to go with it. So the probability of D is 0.6. We times that by 0.3 and we get 0.18. So that is our answer to part A. Before I do anything else, I would now draw myself a Venn diagram, because then everything becomes much simpler to see from that. I didn't bother before because there wasn't too much we could put in. All we knew before was that C given D was 0.2. Can we put that down? No. Can I put down 0.2? I know they add up to 0.2. I know that adds up to 0.6. I know if I add them together and take it, but I don't know what's in the middle yet. So I've worked out what's in the middle. That's 0.18. Now that I've done that, I can work out the rest, because if C if that's 0.2, then that's 0.02, isn't it? If this is 0.6, 0.42 plus 0.18 makes 0.6. Now I've got all 3 of those. I can add them together. 0.2 plus 0.42 is 0.62. So then I can say 1 take 0.62 equals 0.38 to be the probability that neither of them happen. Right, now what do I want? The question is saying D given C. So I know that C is 0.2, and I know that, no, that's not what I want. Yes, D given C, it is what I want. Then the chance of getting D within that is 0.18, so it's very likely that you're going to get that. I'll put a little 20 under there to make it easier to call that 9/10 or 0.9. Then, as we're in decimals already, let's stay with decimals. Part C, C union D, that's all 3 of them, isn't it? So all we have to do then is add those 3 up, or add 0.42 on to 0.2, which we've already done, haven't we? And gives us 0.62. Hope that helps. We've got one more example to come. No, we don't. That was our last example. All we need to do is have a bit of a practice of this. So we're looking at exercise 2D on page 29 and questions 1, and then the exam one's 9, 10, 11 and 12. And if you can do those, then you pretty much got it sussed. Okay, see you next time for tree diagrams.